Talking today to Gerry Collins, who is the Head of Business Development for Altobridge, who do low-cost solutions for remote areas in terms of GSM coverage. Gerry, tell me, why is the Altobridge solution that much cheaper than everybody else's solution?
Well, when we say our solution is cheaper, what we really mean is we focus on reducing the operational cost of a remote solution. And that means focusing on the two major cost components of running a mobile system in a remote area. Again, when we talk about a remote area, we're talking about areas which are both off the electrical grid and also away from any other form of communication. So you're reliant on satellite for backhaul. So we look at those two elements, the energy and the satellite backhaul, and we look to optimize them, because for us they represent roughly about 80% of the operational cost of a remote mobile solution. So we focus initially on the energy. So we run our Altopod, which is our remote site equipment, really to optimize the energy used, and we get it down to roughly about 90 watts, and that we believe is roughly about 30% more efficient than any of the competitive solutions. And we do that through a number of ways. We use 10 watt amplifiers, so we're able to get roughly between 3 kilometre to 10 kilometre coverage range. When any of the channels are not being used, when either of the TRX is not being used, they're switched off. If any of the channels or any of the time slots are not being used, they are switched off as well.
You're using a smaller mast, aren't you?
We're also using it as a smaller mast. So our belief is that what you really want to do is you want to target this kind of key coverage area between 3 and 10 kilometres, and that can be achieved in a large number of areas with about a 12 to 15 metre mast. So if we put our base station equipment onto the mast, it's basically right beside the antenna, so you reduce the amount of losses as well. So you've got optimum coverage for the amount of energy you're actually putting into.
And the base station can be put up in a day, 2 days.
Yeah, so we focus very much on reducing the total solution cost and deploying it day one. You really want to keep that cost to a minimum. So you minimize the cost of the tower. So as I say, we focus on a pylon which is between 12 and 15 meters. It can be constructed with three sections and can be constructed by 2 men within a day, maximum 2 days. And again, you have an optimized solar energy system. Again, just coming back to the energy, we get it down to 90 watts energy, and that means that we can actually run the system exclusively on solar energy. So immediately, one of the major operational costs, which is the cost of energy and the cost of diesel or the cost of a generator or cost of electricity, is reduced basically to zero. That initial investment in your solar system, your solar energy system, will bring that operational cost down to zero. And that's because of the optimization we do in terms of the energy usage. The other main optimization that we do to bring the operational cost down to the lowest possible is optimization of the traffic on the backhaul.
Yeah, this is the satellite side of the problem.
Exactly, yeah. So how can satellite bandwidth is expensive, how can you ensure that you can reduce the cost of your satellite backhaul on a monthly basis? So we reduce the traffic in a number of different ways. One is we use the most efficient codecs available in the industry, the AMR half rate codec, roughly between 4 and 5 kilobits per voice channel, and we maintain that codec right the way through the network. We don't re-encode at a higher level.
You don't step it up.
We don't step it up at all. So basically, once it goes over the backhaul, over the satellite, you're at between 4 and 5 kilobits. We then obviously we're using IP, so we're accelerating the IP traffic. We're stripping out the unnecessary headers, the unnecessary overhead that might exist in the IP. But one of the major cost reduction features is what we call local connectivity, which basically says if people are calling each other in the same base station area, in the same coverage area of the base station, that call, the traffic path will be routed locally. So the traffic path stays within the base station.
So you have a controller.
So we have a controller inside what we call the Altopod, the equipment that's at the remote site, which allows you to send the signaling, the low bandwidth signaling to control the call back over satellite, but the actual traffic path and the most expensive part stays locally. And what we see is that, particularly in remote locations, a very large percentage, anything up to 70% of calls on those remote sites are actually local. So you're able to take a massive reduction of the cost of the satellite backhaul. We're also able to do things which is putting the base station when for example, there's no traffic actually being used. During the evenings or during the night time, there's no traffic. Our system, because of our split architecture, part of the intelligence of the base station controller is actually in the Altopod at the remote site. We're able to reduce the idle load of traffic down to zero.
Right, so effectively it switches off.
Essentially it switches off. You don't have any background traffic, and we understand that if you look at other solutions in the industry, this can be a constant up to about 200 kilobits constantly going back and forward over the satellite. So we're able to do that. That has another added benefit in terms of the energy, because you're then able to take advantage of the sleep mode and the satellite modem. Because the base station switches itself off when there's no traffic, and then also
using what's known as Dharma.
Exactly. So we're able to optimize, both on the base station side and on the satellite in terms of the energy and the backhaul used. So we believe we can get the total monthly cost of the satellite backhaul down to between $250 and $300, and we've got plenty of evidence in the market now that that's what we're able to do. So if you take the energy costs roughly down to zero, and you're able to take the backhauling costs down to about $250, what we're able to do now is make communities which were previously seen as economically unviable for the operator are now actually viable. And this is
so let's just talk about, in a sense, business case. You're talking population densities as low as 30 to 50 people per square kilometre.
Yeah, no, absolutely, yeah.
And you're talking about the kinds of places where maybe there would be markets once a week that would generate traffic.
Yeah, I think one of the most interesting things we've done recently is we've looked at, particularly our most recent deployment in Africa, is looking at the classifications of the different types of sites that we're deploying. What are the population densities? What is the pattern of activity which is going on in these places? And we've looked at obviously towns, villages, settlements, major road junctions, mixtures between settlements and junctions, and to see what are the type of traffic patterns and which of these, what is the type of business case. One of the most encouraging, there's a couple of very encouraging things we see. One is that traffic rarely starts from zero. These systems are turned up, and you realise actually there's a lot of people have phones in these communities, and they're just waiting for the signal to up. So you never see a traffic graph starting from zero. It starts at a number of airlines, 5 or 6 airlines already. So that's encouraging. But also you see an impact, particularly in the kind of the classification of towns and villages, is that the market days, you can see a tripling of the traffic on the market day. Of the traffic, and again it's all very good news for the operator, in that not only are they capturing almost exclusively the people who live in that particular village or town, but you're also then forcing the people that are coming in to do business to basically buy a SIM on their network. So you're getting a whole lot of captive customers, but also potentially you're attracting customers from your competitors, because the people who want to sell their stuff in the town that day have to get onto that operator's network. So there's lots of impacts.
You've got almost a sort of catchment area effect, because though the 3 to 10 kilometres is not very large, you will get people who will walk into the catchment area.
And that's what we see, is that and there's we see people coming in. We also tend to see, one of the things we do in terms of our analysis is to look at the activity level in the site as a function of distance from the, and we do see that the vast, even sites which do have kind of the 10-12 kilometre coverage range, the vast majority of the activity is happening within 3 kilometres. And I guess this is probably because the sites are being properly placed, and the town or the village actually doesn't spread much further than that. But yeah, you do see a kind of a concentration and people, coming towards the area where they know it's going to work.
So what kinds of locations are you deployed in Africa, and sort of, if you can tell us where or what operator, if you can't, give us some general idea.
We're still under a certain amount of NDA with our major customer there, but we're in West Africa. We're in a country in West Africa, one of the poorer countries in West Africa where wealth levels are challenged, but we've been able to turn around a positive business case. We're in locations which are quite distant from the main city. We're talking about it takes 2 days for the engineers to get out to these sites.
Yeah.
So they're significantly rural. They are. Whereas a lot of the work, some of the work that we've done in Asia has been focused around enterprises. The vast majority of the sites that we have deployed in this particular African deployment are very much, it's habitations. It's where people live. It's remote areas, remote towns, villages, as I say, crossroads in these rural areas. Only a very, very small percentage of the sites are actually focused around where there is a particular enterprise. So for us, it's a very pure example of what we want to do, which is actually bring communication out to where people are actually living and spread it out to the rural areas. So it's we believe that the kind of proof, we've gone beyond proof of concept, but what we've done so far in Africa really proves that you can go out to areas that basically have the population densities of 30, even between 20 and 50 people per square kilometre.
And lastly, you're developing a data product. Just briefly tell us what that's going to be.
Yeah, so we look at the we look at the competence that we have as a company, and a large part of the competence is how we optimise IP backhaul streams. Obviously, the majority of the IP backhaul streams at the moment are in mobile broadband and that massive growth. So we're looking at how our competence can allow companies to basically optimize their mobile broadband backhaul by basically analyzing what is going on in the traffic streams. Doing a lot of smart things with IP, but also looking at the content level and saying, is this content being used by more than one user in a particular cell site? So, and if it is, and if the classic example is a YouTube video, if a particular YouTube video is popular on a particular day, and that 10 or 15 people are going to be looking at it, why send that over the backhaul 15 times? When you can actually pre-position that content, cache it locally, and as the cost of memory etc. has gone down, you can actually cache a significant amount of information locally at the base station site. So that's what we're doing. That's a product called Data at the Edge. We're talking to a lot of our customers about it. We're in trials in certain areas with that product combined with our 3G remote community solution, and that's the future of the company. But our focus is still very much in terms of how we can get out to the remote communities all around the world and get to the 2 billion that aren't yet connected.
Gerry, thanks for talking to me today.
Thank you very much, Russell. Thank you.